Hey, this is the tutorial that I made for my component that I created. This is a component that you can put on any one of your characters and have them be able to ragdoll, and not only just ragdoll, but have a server authoritative ragdoll system. So on the right side is the server, and on the left side is the client. So usually in this situation, you'd see the client and the ragdoll falling if you had a replicated system, but they would start to appear in different spots. This keeps the correct location. However, we don't care too much about the exact position of the limbs. So I'll stand up now. And as you see, when we stand up, we are in the exact same place where we were when we were being ragdolled. So the server sees where the client is, the client knows where it is, and it knows where the server is at all times. So let's get into it. Basically, we have our third-person blueprint, and we'll show you that real quick. So you just want to add the Ragdoll Net proxy component on top of the into the third-person character, or any character that you have. So if you have like a horse, for example, you can do the same thing. As long as they have a physics asset, it should be able to link to it automatically, and then it will use that mesh and physics asset respectively to perform the ragdoll. So we have the very simple setup. Basically, you just have your trigger. For me, it's just press number 1, and that will set your ragdoll up to start ragdolling. We do have a launch velocity attached to it. I'll explain that later. And then we have our stop network ragdoll. Right here, right before you do a stop network ragdoll, you can put your animation to get up. So if you have an animation that goes, from back to stand up or from front to stand up, you can do all that logic right before you do stop network ragdoll. Next, we're going to do everything one by one here. So let's minimize all this. So we have a follow bone name. So this will be the pelvis for most cases. You can change the bone name if you want to. This is just for the capsule to follow the mesh. So something that I did that I noticed worked really well is detaching the mesh from the capsule itself, like fully detaching it, and then reattaching on the stop network. So instead of having the capsule follow based off of, they're attached over here all together, it's a separate follow mechanism that I do for the capsule. You can turn it off, and you can do that here for the capsule collision. You can keep the capsule collision on, or you can disable the movement while ragdoll. If you do disable the movement, like I have now, you'll just get the camera to follow. If it's disabled, then you'll be able to move the camera around. Some people would like to have that just for to be able to keep the camera, in control of the character or the person. Enable capsule prediction lead. This is something that you'd want to enable if you see you're going down a hill really, really fast, and you have your root sync. Yeah, if your root sync number is really low, like in the 20s, you will probably want to keep this on. The reason is because sometimes you'll get a little bit of twitching if you're moving at high speeds, and you have this really low, and the capsule lead is not present. Then you'll get a lot of, not teleporting, but you'll get a lot of catch up. So the mesh will get ahead of the capsule, and then it'll have to catch up. But if you do the prediction lead, it always kind of puts a lead in front that allows it to kind of predict where it's going to go, and then it's a little more smooth. But if you put the number up to about 60, then you're fine. This is only if you want to put it down to 20 and have like 30 people ragdolling down a hill, which is possible with this. So we'll keep that unplugged for now because we're going to keep it at 60 because we're only doing a test locally here. and it's pretty smooth with that. So that was your prediction for your capsule. Next we have a stand-up. So this is going to be any kind of, if you want, you can do a automatic recovery, and that bases off of if your capsule is within a certain range of your mesh. So once the mesh gets to a certain point and stops, and then the capsule catches up, your mesh or your character can automatically stand up. So that's one thing that I added that you can use. And then there's base follow speed multiplier. So this is for your capsule component follow. There's a small error past a certain amount. So if your capsule goes past or lags behind by 25 centimeters, then you'll get a speed boost of 100 on the capsule just to catch up. If you're past 120 centimeters or lagging behind by 120 centimeters, you'll gain this speed to catch up back to the capsule, or at least to the predicted spot like I was talking about before for the capsule prediction. You have a minimum speed and a maximum speed that you can always change if you want, but I find these are good values to keep. Come on, kitty cat, what are you doing? I'm trying to make a video here. Hey? Come on. All right, you can stay here. These values here are values that you can use for client root position. So these are kind of like the bone samples that we use. So we do a sample of the positional and rotational vector, so that we can kind of see where the bone is currently on the client side and do a interp to the next position. So because of the time that we use here for the server root state update, so this, if it's 20, that means every time that this updates, you'll get a quick sample of where the bone is, and then from the previous one it draws kind of a line of where it's supposed to be, so it's kind of predictive that way. But then when the next update comes, we get the real position, and it'll try to it'll try to take that and go to that real position. So it'll go from where it was to the new position, and it'll do an interpolate. So it basically will go smoothly over to the next position. So you can see when it's going down the hill, it's not very choppy on 60, but when you put it down to like 20 and stuff like that, that's when you can start to notice the interpolation on on very like high speed drops. So if you're going down like a mountain or something like that, like I showed in the video, then you'll be able to see the ragdoll kind of go down and fall and go faster and faster, but then you start to see the kind of interpolation start to kind of fail. And then we have the momentum. This is your momentum when you're running, and then you jump or whatever, and then if you ragdoll at that moment, it'll take the capsule movement speed, because like I said before, the mesh detaches from the capsule, so it'll take the mesh or the capsule speed and translate it to the mesh, so that the mesh, and it'll translate it to the mesh's pelvis area, which is basically like the root of your bone, and then that would translate to the mesh, and then you would see the ragdoll continue moving forward. We do added downward fall velocity to kind of make it more realistic. You can change all that as well. Another thing that I did is impact impulse scale. So this one's really fun, really cool. We have impacts. So you can go to you can change the bone name, by the way, too. It doesn't have to be head. It could be whatever your skeleton uses. You could change that. Mine was just linked up straight with the Unreal Mannequin. So spine 3 for the center mass, clavicle, right, pelvis, whatever. So what this does is this allows you to take a hit from something and ragdoll into that direction that it hit you from. So if someone shoots you, it'll basically, you will do the math on the trajectory, where it hits you from, and then input those values into the launch velocity vector. And that will, if I give an example of that, let's do for the head. We can save this, go. And so this will be launch velocity on the head itself. So if we close this and close this and close this, I'll show you, oh no, this one. So that'll be on the head bone. So you can see right here, and we can change this. This could be like the foot bone L, like foot L, and then it would hit the head, the L. This is just the name of the actual bone itself. So you don't have to have it be head. You could name it a different bone if you wanted. But for all intents and purposes, to keep everything lined up, I just named it head. So if you get hit in the head, then this is what will happen here. So from the head, as you saw in the back of the head, kind of fell over. So we get this guy going, boom, back of the head. It's hit, falls over. If you're jumping, so if you go to jump and you press it, it gets launched from the air. So if something hits him, or a bullet hits him or whatever, then you'd be able to see that impact take effect. Now, for right now, if I was to do it now and I jumped up, you can see it hits backwards. So that's where you would do all the math to figure out your trajectories and your vector launch velocities. And then you just feed it into that and click which bone you want it to hit, and away you go. I think that's pretty much it. Like I said, it's a very easy system to use. Everything's well documented. And on here we have two very easy ways to get started. Start network ragdoll and stop network ragdoll. That's it. Thank you very much. Bye for now.